In this video, we present RNN Multi-Explorer, Visual Interpretation of Recurrent Neural Network on Multidimensional Time Series Forecast. The interface consists of 5 components: Configuration Panel View, Cluster View, Feature Importance View, Projection View and Individual View. From the configuration panel, users can select a model to analyze. The spatial partitions and cluster view will be shown after a model is selected. The region near to the target location are partitioned into 40 subregions. In the cluster view, the left column are the hidden unit clusters. In each cell, we use a line chart to visualize the hidden unit activation distribution. The right column are the feature clusters. We design a glyph to encode the input feature. The background color shows the feature type. A line with one endpoint at the glyph center shows the direction to the target location. The size of inner rectangle indicates the distance to the target location. The features in each cluster can be sorted by direction, distance, or type. After selecting a model, user can choose a target feature for the further exploration. Feature Importance View will appear to show the general feature contribution to forecast the target feature. When hover mouse on a feature, the corresponding item in the cluster view and the region in the configuration panel are highlighted. To explore the case similarity, all the cases in the test data are projected onto the 2D canvas. The color of the circle indicate the model output as shown by the legend. User can query the subset of data by feature or time. We select the time range of winter and summer. A clear boundary can be found between the cases in the projection, which shows the feature learned by the model can distinguish the seasonal pattern. In this case, we explore the case difference in the spring 2018. We first select outliers in the spring. These individual cases are visualized by individual views. The individual view consists of 3 segments, and all these 3 segments share the same horizontal axis indicating the time. Feature trend chart visualize the temporal feature value by timestamps. The cluster importance view visualize the contribution of feature clusters by horizontal bar chart. The top feature view ranks the features according to the overall importance in one case. Since there are too many individual cases selected, we cluster these cases into 2 groups by using dbScan, and visualize them into 2 stacks. To make a comparison, we select several normal cases and form a new cluster. Then we compare the severely pollution cases and the normal cases. In the polluted cases, we find the cluster 10 have great contribution in the forecast. When hovering on the cluster 10, the corresponding cluster will be highlighted in the cluster view. This cluster is dominated by the wind speed-based features. On the contrary, the most important feature cluster for the non-pollutant cases is cluster 7. Which indicates the local PM10 and PM2.5. But this cluster is not important for the pollutant cases. And the cluster dominated by faraway PM10 and PM2.5 are important for polluted cases, but it is not important for the non-pollutant cases. From the feature ranking chart, we are able to know which features important for a single cases. In discussion with the domain experts, we know that the air pollutant in Hong Kong are from Pearl River Delta. For the pollutant cases, the faraway's pollution and wind are important factor to make the forecast.